Hello, welcome to this demo of the near real-time RIC deployment for the F release. My name is Torab Chihi. I'm the PTL project technical lead of the near real-time RIC project. I quickly put here a list of what we're going to do in the demo. First, we assume that there's a fresh Ubuntu 20.04 installation. On top of this, using scripts from the near real-time RIC platform, we install Kubernetes Helm and base charts for the near real-time RIC deployment. And then we actually deploy the near real-time RIC. After this, compile and connect the ORAN E2, ORAN SC E2 simulator, and also connect the Nokia E2 simulator just to have multiple simulators connected to the same near real-time RIC. Then we deploy the DMS CLI, the deployment command line tool for deploying XApps, and compile and onboard and install the Hello World Go XApp. This slide, all the scripts, all the commands used in this demo are available at the link here at the bottom. For the demo, I use a pre-recorded session, terminal session, so things might go quite fast. So we don't have to wait for all the commands that take a bit more time, like downloading Docker containers. We don't have to wait for those. First, let's start by looking a bit at the near real-time RIC web pages and where to get the information for deploying the near real-time RIC. So you can see here under introduction and guides, there's a link to the general latest instruction from the deployment repo, and there at the very bottom are a link to the instructions how to deploy the RIC and also how to deploy the near DMS CLI. Then we have here, these are the instructions on how to build the E2 simulator. So let's start. So let's stop for a second. We have 1 to 4 terminal sessions here. Most of the things will happen in the middle one. Later in the upper 2, we deploy the simulators, and in the lower one, we deploy the XApp. So let's see what's happening. We just take a look at which Ubuntu version there is. Clone the RIC dep depot, which is the first step as per the instructions. And then we actually start the installation of Kubernetes and Helm. This takes some time. We make a jump to the end of this. You see now that the Kubernetes system pods are deployed and running. And then as the next step, we will actually deploy the Helm, common Helm charts. For this, we run another script from in the same directory, which will finish quite quickly. Once this is done, and here is a special step that I personally find useful, but it's not mandatory. I have here the list of Docker containers that are actually used. I put them into a file. The file is aligned with the actual recipe that is used for deploying the near real-time RIC platform. So I quickly show here the recipe, and in that recipe, the versions are exactly the same as in this file that I used. So you could at any point in time extract them. For instance, for Alarm Manager, this is the registry, the name, and the tag that is used. So using this, I will pre-deploy the pull all the images, and once they're pulled, we can actually instantiate them on this Kubernetes instance. Otherwise, they would be pulled by Kubernetes as part of the startup of the containers. And I find it better to first pull them and then have the second step execute faster. So this is a small script that pulls them one by one. Again, this will take a lot of time. we jump forward. Now they're all pulled. And now we can actually start the installation of the near real-time rig. First, we need the IP address of this particular node. It's this one. And we have to add this in 2 places in the recipe file, which I'm doing here. And once this is done, we can actually start the installation with this recipe file. Again, the installation will take some time to execute, and we jump then to the point in time after the installation has succeeded. And now we can see the near real-time rig platform pods actually running. Now in the upper top window, we started the compilation, or we start to compile the E2 simulator from the O1SC simulator project. The first command is just cloning the repo source code. And as a next step, we have to install some prerequisites, CMake, compiler, and the libsctp libraries. This will take some time. And after this, we can actually then start the first step of the simulator compilation, which is creating certain Debian packages, which are then used in the Docker stage of the compilation. Before this, I don't like particularly the way how the simulator project is started as a Docker container. So what I did here is modify the Docker file at the end, which command is actually invoked in the container, as you can see here. Originally, it directly invokes the simulator, and the instructions recommend to replace the IP address here with the IP address of the E2 termination on the near real-time rig side. I just put a sleep here, and then we execute into the container, put it, and from a shell actually invoke this command. Once done, we create a build directory. I do the first step. That's not Docker related yet. So let's wait until this completes. It's relatively fast, it takes less than a minute. We copy the Debian packages in particular directly. All these instructions are available at the web page in the link from the first slide. And now the actual Docker container creation starts. And before we start this, note that I just put a tag here on that container. The result will be locally stored, so it doesn't really matter what you put here, except that later you have to use exactly the same tag. So once it's started, this will take, we jump to the end of that again. So now the compilation is, the container creation is done. As you can see here again, there is the tag name. I did some small mistake here. I just ignore these two lines. Now we actually run the simulator. With this command, you see the tag here. Now it's running, it's just sleeping, so it doesn't actually do anything yet. We execute into the container. And from there, we can run the simulator with exactly the same command as earlier. The port number will be 36422. And before that, the parameter will be the IP address of the E2 termination. We now in the middle terminal, you see here, we find the IP address, simply looking at the services, and you will find it here. And that's it. Now, when we start the simulator, it will connect to the near real-time RIC platform. In order to show this, we need, let's see what's happening. We need the IP address of the E2 manager, and then we can run this call command to query the current connected E2 nodes. So you see here, this is the IP address that we will be using. We copy it here, and you see once we run this, it returns an empty list. There's currently no E2 node connected. Now we start the simulator, it connects, and when we run the call command again, it will show one connected E2 node, this one here. Now, just for demo purposes, I also show our internal Nokia G-Node B simulator to show that there can be another connected simulator. Again, here we have the IP address of the E2 termination, the same one as before. And there is another parameter that I originally forgot to update, which is the IP address of the node where this simulator runs. That's why this first connection will not succeed. This IP address is needed because the Nokia simulator binds to the source IP address, and because the wrong IP address is there, it cannot actually bind it. So what I'm doing here is quickly find out what's the IP address of the node and place that in the correct parameter. The open source simulator doesn't have this source address binding. There is a feature that we might work on in the next release to provide this capability. So now it runs, it connects to the near real-time RIC, and there should now be two simulators connected, as you can see here, number 1 and number 2. As the next step, we should be installing the DMS CLI. The first step in this is to run a chart museum, a chart repo. This is the first command here that you see here. These were not the correct commands, so this is the correct command. It downloads the chart museum image and just starts it up. This should go pretty quick. It's a small image. And now we are following the instructions for installing the DMS CLI. You have to tell the repo URL that we just run. We clone the app manager repo with the correct release tag. And then in the XApp onboarder, there are a couple of steps we have to do. We have to, this was pretty quick, we have to install pip packages. Again, all the commands are available in the RIC tab documentation. Just in case the onboarder was there, we delete it. Now we install it again into the local pip Python installation. It will take some time. And now we still modify permissions in the instructions. The instructions are for Python 3.6, but here in this installation we have Python 3.8. So you might have to do a small modification in the change mode commands that command that comes next. So it has to be 3.8 at the end. As next step, we will install the Hello World Go, or compile the Hello World Go and deploy it. So first we clone the source code repo. And this is also pretty straightforward. We build it, and as you see here, I give it it has to have a tag. This URL here can be anything, but it has to be later used. It anyway will only put it into the local Docker registry. And then these two tags can also be anything. The key thing is because of a limitation of the DMS CLI, this cannot be empty. We have to put something there. I put here example.com/port 80. So this has completed now. You see here again the tag. And now we have to modify the config file for the deployment and place exactly the same values here in the registry. This example.com. The name will be hello.go, and I think the tag was 1.2 if I remember correctly. This config file is then used when deploying the actual XApp. So now we onboard the package. It has been created in this local chart museum. Here we still show that there are currently no XApps deployed. There was a small typo. And now we actually install it with the install command. And once it's getting installed, you will see now, maybe don't focus on the actual command here, DMS CLI and blah, blah, but in the upper two windows, we still have the two connected G-Node B simulators. And one of the first things the Hello World Go XApp will do, it will make E2 subscriptions to all the E2 nodes that it finds are connected. So you will see here in both of these something happening. And that's the fact that they receive these E2 subscriptions. So let's see how that happens. So you see here the E2 subscriptions have received. There's a lot of output up there, which we can't see now. And then in the middle, we still show that there is a deployed XApp, the Hello World Go XApp. That's it for this demo. I appreciate you taking the time to take a look at this demo, and please try to follow those steps. Thank you very much.